Good morning to those of you on the West Coast. Good afternoon to those of you joining us from the East Coast. And good evening to anyone joining us from Europe or stations further east. Thank you for joining this, the 35th of our regular series of short courses on pumping topics. This one will last about 35 minutes, allowing us time for a Q&A session at the end. As in previous sessions, we're trying to maintain educational content rather than product placement. So I have included slides of other our competitors' products. As usual, I'll include a few slides at the end of the presentation to remind you of who we are and what we do. But I don't dwell on them. They will be in the PDF copy of the presentation you get, so you can peruse them at your leisure. Here's a listing of all the previous short courses we've run during the last 3 years. If you've missed any of them, you can get a copy of the materials from our website. Go to ruhrpumpen.com and follow the link to RP Short Courses. If you go to ruhrpumpen.com, you get to this screen. And here is the link to RP Short Courses. If you click on that, it takes you to this screen. And you'll see all of the recent courses listed. Here, I just show the latest 4. But you can click on any of them to download the course material, either the full video, the presentation as a PDF, and the Q&A report as an Excel workbook. Well, this seminar is going to look at vertical sump pumps, API type VS4. We'll look at the general industrial model, commonly used in water and wastewater industries, and at the API 610 version, used in chemical and oil and gas industries. We'll be holding a Q&A session at the end. Of course, it won't be fully interactive because we've got about 270 registrations for this afternoon session alone. So with that many people, it can't be fully interactive. So please use the Q&A facility at the bottom of your screen to ask any questions or to make any comments. I will address those that I can live at the end of the session, and the rest we'll address by mail in the coming days. And we'll pull them all together into one Excel Q&A spreadsheet, and we'll send that to you with the course materials. We're recording the session as well, and we'll make it available to all attendees as a YouTube link, as well as by emailing you a PDF version of the slideshow. So here we go. VSPs. VSP, which is a VS4 pump. And there are many manufacturers of this type of pump. Ruhrpumpen, of course, Flowserve, Sulzer, ITT Goulds, Marelli, KSB, Amarinth, Koloska, Ibarra, and literally dozens of others. Now, in the following slides, we're going to show 2 constructions of pump. The standard construction water and effluent pumps, and the semi-engineered API 610 version. Now, most of the manufacturers I mentioned a couple of minutes ago, they manufacture in a pretty similar way. So what I'm showing you here is not unique to Ruhrpumpen, which is in line with our principles of making these courses educational rather than product placement. So here on the left, we have the VSP, vertical sump pump, standard construction. And on the right, the VSP Chem, API 610 version for the chemical and process industries. Here's a summary slide for the standard construction, the water and wastewater pump. It's the VSP, and it will handle Solids up to 1 5/8 inches, 41 millimeters in diameter. Standard construction is cast iron, has grease lubricated bearings, a grease lubricated thrust bearing, and a threaded discharge pipe here with a threaded on flange. And it's available in 33 hydraulics in the standard version and 11 more for the non-clog pump. And this is the solids handling, the non-clog pump. Will handle solids up to 6-inch diameter, which is 150 millimeters, and it comes in cast iron and 316 construction as standard. It has 11 hydraulic sizes. Now here is a summary of the API pump construction, the VSP Chem. So it's to Hydraulic Institute and API Designs. It has a semi-open impeller and also an HHLF impeller. Now, HHLF means high head, low flow. It's a Barsky impeller. And there it is, in case you're not familiar with a Barsky impeller. It's available in cast iron or API materials. So it can be stainless steels, duplex stainless, and chrome steel, for example, as well. So, and duplex stainless and super duplex stainless. It has a grease or external flush or self-lubrication for the line shaft bearings, and either oil bath or grease lubrication for the thrust bearings. A welded discharge pipe with a welded flange on the top. Circular mounting plate to suit tank mount options, but it can be square if you prefer. And these are the typical applications for this type of pump, both API and non-API versions. Now, VSP Chem pumps are often installed in horizontal cylindrical tanks. Usually this kind of applications, if they're for hydrocarbon transfer and for waste from process waste. And sometimes these tanks will have a boot fabricated into the bottom, and the pump will sit in there below the tank, such that that it improves the NPSH available. VSP pumps are often installed in open tanks to avoid water overflow from the collectors, and they're frequently used to collect effluent from many processes in general industry. Now, these pumps, generally being installed on open tanks, have a square mounting plate to mount on the tank structure. Here's the performance range for the 3 different types of pump. Here's the industrial pump, the VSP. And here's the VSP non-clog. The capacity actually is a little higher than this now. We've added a couple of sizes since this slide was written. And here the VSP Chem goes up to 1900 cubic meters an hour, or 8,400 US gallons a minute, which is twice the flow range of Flowserve, Sulzer, or Gould's. Solids handling capability is an important issue for some pumps. Here is a chart of the standard industrial VSP. You see the maximum solid size varies with pump size, as you would expect, from 3/8 of an inch, 10 millimeters, to 1 5/8, 41 millimeters. And here for the chemical process pump version, the VSP Chem, it's a similar range of solids handling. Now in these charts we have solids handling pumps. First, some VSP chem pumps are designed for paper stock, and they will handle solids from 1 inch to 2.5 inch, so 25 to 65 millimeters. And here are the VSP non-clog hydraulics, considerably larger solids, 3 inch to 6 inch, so 80 to 150 millimeters. Let's look briefly at the range charts. I'm going to show you several range charts. I don't propose that you try and read them right now. I suggest when you get the hard copy of this presentation, you print them off and keep them in your top drawer where it's useful. But here is the standard pump at 60 hertz, and we see it goes up to about 4,000 gallons a minute, which is 900 cubic meters an hour. And here again, the VSP at 50 hertz, up to about 750 cubic meters an hour, which is 3,500 gallons a minute. This chart is for the non-clog pump at 60 hertz, goes out to 2,000 cubic meters an hour, 9,000 gallons a minute. And the non-clog at 50 hertz speed, 8,000 gallons a minute, 1,800 cubic meters per hour. And now the VSP Chem. I only have a 60 hertz slide to show you here, I'm afraid. I'll have to check into whether there is a 50 hertz slide or get one for you anyway. And the range chart here shows it goes out to about 1,900 cubic meters per hour, which is 8,400 gallons a minute. So a very comprehensive range of API pumps there. Well, the next few slides show the construction features of the VSP, the industrial pump. Here is an overview. In the next two slides is the top half of the pump and the bottom half of the pump. So we start with the cast iron frame, motor support, shaft coupling, thrust bearing, square or round mounting plate, threaded on flange for the discharge, grease lubrication as standard. And here are the line shaft bearings again that are grease lubricated as standard. So a tube fires the grease into each one. And moving down now, we have the pump case and the cast iron or stainless steel semi-open impeller. Bronze bearing bushing, again, grease lubricated. Here is the discharge pipe. Side discharge comes all the way up to the surface. And here, basket strainer, which is typically galvanized steel or steel. And as I say, we will look at each of these in a little more detail now. So here's the motor support, which incorporates in here the thrust bearing. It's designed to take either a NEMA C or an IEC D frame motor. It has a cast iron casing with either a cast iron or a stainless steel impeller. Here's the basket strainer again, and the bronze line shaft bearing, grease lubricated as standard. Looking now at the impellers, here we see two standard designs. On the right is the normal impeller, the semi-open impeller, and on the left, the non-clog impeller, with much larger flow passages, as you can see. The discharge pipe is threaded and fastened to the mounting plate by two nuts, one above and one below. And the flange, the ANSI flange, is threaded onto the discharge pipe. Grease lubrication is standard on VSP pumps, although you can have options of clean external fluid flush and product self-flushed bearings. They're available, but most common on these VSP pumps is grease lubricated bearings. And there's a pipe to each individual line shaft bearing. The square type mounting plate is standard for mounting on open tanks. They can be circular or custom made to suit an existing installation. It's a grease lubricated thrust bearing, single row or double row bearings, depending on speed and therefore thrust. Pumps running at 4-pole and 6-pole, we can use a single row bearing. If it's a 2-pole, we need a double row bearing to handle the thrust. Looking now at sealing, if the pump is going on an open tank or pit, then there's no point in sealing the shaft in this area. There's no flow, there's no fluid in this column pipe. Remember, all the fluid is coming up the side discharge up here somewhere. So if it's an open tank, then you're getting fumes anyway from the open tank. What's the point of stopping it, the very few fugitive emissions from coming through here? But if it's a closed pit or tank, then you probably want either gland packing or a mechanical seal here where the shaft passes through the head plate for odor containment. Well, the next few slides show the construction features of the API build pump, the VSP Chem. Here is the motor support, a steel motor support on the API version. Remember, it was cast iron or steel on the industrial version. It's designed to support a NEMA C or IEC D-frame motor. On the VSP Chem, it's normally a round surface plate, a circular surface plate, drilled to match an ANSI flange. But it can be square if it is going to be mounted on an open tank structure, sitting on I-beams or channel sections. Either way, it has lifting lugs and grounding lugs. The pump case and impellers can be any of the API materials. It can be steel, chrome steel, 316 stainless steel, duplex stainless, as well as cast iron. The bearings are petrocoke tape, essentially graphite bearings. Optional shaft sleeve in the bearing area if you're handling abrasive fluids. And the impellers are lock-keyed and they're held on with an impeller nut, which is locked against accidental reverse rotation. Here's the discharge, side discharge, and you see it is welded, a full penetration weld at the head plate and for the discharge flange. And this is per API 610 requirements. Remember, on the industrial pump, it was threaded at that point and at this point here. We have three types of line shaft bearing lubrication. Here we see the grease lubricated line shaft bearings with separate lines for each bearing, as it was for the industrial pump. Or you can have an externally flushed line shaft bearings. Usually it would be clean filtered product. One flushing line with T's off to each bearing. And the third type of connection, third type of lubrication, beg your pardon, is self-lubrication. So flush is taken from the discharge and into a T-piece here and to each individual bearing. The mounting plate might be square or circular. The circular plate is supplied for tank-mounted applications, and it will be machined and drilled to match an ANSI 150 or 300-pound flange. The square mounting plate is typically used on open tank installations, where it sits on I-beams or channel sections. Again, always has lifting lugs and grounding lugs. Sole plates can be supplied. You would set these in place while pouring your concrete foundation. They have jack screws to level them before installing the pump. We show here a square pump head plate. It could equally well be a circular plate. It's a fabricated steel mounting bracket on the API build pump. Remember, it was cast iron on the industrial pump. The thrust bearings are installed in this motor support. Can be grease or oil lubricated thrust bearings depending on the size and the specification. Here's the oil bath lubricated design. Double row bearing for API build, constant level oiler with sight glass, and labyrinth seals above and below to hold in the oil. Optionally, grease lubricated bearings. Again, the single row bearings at 4 and 6 pole speed, and double row at 2 pole speed, and all API build pumps. The sealing options for these VSP Chem, the API pumps. Well, standard construction on an open tank would have no sealing in this area. There's no pumpage in the pipe, so maybe only a few fumes can come through. But if you like, you could have a lip seal here. A pump mounted on a fully enclosed tank will need some sealing at this shaft penetration of the head plate to prevent vapors and fumes escaping and going into the pump room. It could be packing. It could be a mechanical seal suitable for the process fluids. Typically, it will be a dry running gas seal, but it could be a single wet seal or even a dual seal. The pumps are designed for conventional flange-mounted motors, either IEC D-flange type or NEMA C-flange type. No thrust capacity required in the motor. The thrust bearing is in the pump. So these are standard motors. You need a flexible coupling to connect the motor to the pump. Now, in a VSP standard pump, it's an L-jaw design. So here's the rubber insert, and here's the steel flanges. And for the API pump, the VSP Chem, it will be flexible metal element couplings. So like a metastream coupling, for example, supplied either with or without a spacer. Now, API 610 would require a spacer coupling here to allow you to remove the thrust bearing and the mechanical seal without having to remove the motor from the top. But on smaller pumps, it's generally easier to remove the motor to access these than it is to access them through the coupling spacer. So it's quite common to have a non-spacer coupling here, and that reduces the height of this element as well. Commonly supplied accessories, level indicators, temperature indicators, RTDs, and accelerometers. A variation on the VSP Chem is a jacketed pump. And this is commonly used for molten sulfur, where the sulfur would, if the pump ever cooled down, it would solidify. And when you heat it up again, it will go back into the liquid form. And we achieve this with a steam jacket. You can see a steam jacket here on the discharge line and on each of the column sections. There are 4 column sections in this particular case, and the steam supply is passing from one to the next, then across and back up to the surface. Molten sulfur pumps are product lubricated, so a tapping is taken from the discharge line and is routed to each bearing. So the steam comes in here, passes first to the column jackets, passing from one section to the next, then across to the discharge pipe jacket, and it exits at the top, as you see here. There's the steam inlet, and there the outlet. On a molten sulfur pump, you would need a mechanical seal to be installed where the line shaft passes through the mounting plate, because we don't want sulfur fumes escaping to atmosphere. Most likely would be a dry running gas seal, but it could be a liquid seal. Delivery time? Well, the standard VSP is on a 4-week quick ship program delivery time. So that's for standard materials, which is full cast iron. It's available in various other materials, but not on 4 weeks. It would be longer delivery times for special options. In the VSP Chem, standard materials would be cast iron, steel, and 316 stainless, and those are on 16 to 20 weeks. And it will be longer than that if you need chrome 316, D1, D2, or alloy 20, of course. So those are very competitive delivery times, especially this 4-week quick ship program for the standard industrial pump. A quick look at some of the others. ITT Gould's API offering. It's very similar in many ways to the Ruhrpumpen range. Doesn't have the same capacity as ours. You see it goes up to 720 cubic meters an hour, and Ruhrpumpen goes up to 1900 cubic meters an hour. But many of the same options. This is the FlowServe non-API pump. It's modifiable with some API features. It goes up to about 1400 cubic meters per hour, 6,000 gallons a minute. FlowServe have a full API version. That one was a modifiable industrial version. This one is the full API version. Again, many of the same features as the Ruhrpumpen pump. Only goes up to 1,000 cubic meters per hour. But they have, for example, a molten sulfur pump as well. And here's the Sulzer offering. It goes up to about 750 cubic meters per hour, 3,200 gallons a minute. Well, that's it for today's session, apart from the Q&A session in a moment or two. But first off, I just want to advertise the next of our short courses. Next one is going to be on engineered pump packages. I'm very excited about this one. I'm really looking forward to this one. And it's for those occasions when you'd prefer to buy a complete engineered pumping package rather than just buying just the pumps from a pump supplier and having to design, purchase, and build the rest of the installation yourselves. Skids, enclosures, piping, valves, heat exchangers, filters, control equipment, variable frequency drives, instrumentation, all of that, and engineering as well. So it's on the 21st of November, which is in 4 weeks today. Again, there are 2 sessions, one for the Eastern Hemisphere and one for the Western Hemisphere. The invitation will go out in the next week or so put it in your diary. I'm going to leave the meeting open now for a little while to allow you to post in the Q&A box, and I'll endeavour to answer those that only need a short answer here and now. Those that need a fuller answer will be answered within a few days. Anything you think of later, email to marketing@ruhrpumpen.com or to me directly at smith@ruhrpumpen.com. Our marketing team will be sending you the YouTube recording and the PDF of the presentation slides and the consolidated Q&A from both of today's sessions. If you need a certificate of completion for this short course, again, send an email to marketing@ruhrpumpen.com. And here, right at the end, are 8 slides about Ruhrpumpen to remind you of who we are and what we do. They'll be in the PDF copy of the presentation, so you can peruse them at your leisure. You don't need to look at them now. And so what we will do now is get on with the Q&A. Let me stop the screen share and let's have a look and see what we have in the way of questions. Jerome Boller says, how well is an oil level able to maintain the oil level for the vertical axial bearing? Very well. They are very well-established constant level oilers. They're fitted on all horizontal pumps and most vertical pumps as well. So yeah, it's a very, very reliable lubrication system. Daniel Gervais says, could you detail why double row bearings are required when a 2-pole speed motor? Is it related to the upthrust? No, it's not upthrust. It's just the amount of thrust generally. If a pump is running at 2-pole speed, it develops higher heads. And if it's developing higher heads, there will be higher thrust. So you need a double row bearing instead of a single row bearing. If it's running at 4 or 6-pole, the thrusts are very, very much lower. Victor Mihangos says, what is the longest distance from the base plate to the impeller suction in each variation of the VSP pump? And do you build glass fiber material? Distance can be 20 foot is standard maximum. It can be longer. A bit more engineering required when it's longer than 20 foot. For a start, you need 2-piece shafts, for example. So it can be longer, but 20 feet is the standard maximum. And as for glass fiber, I don't believe we've built these pumps in glass fiber. I'm pretty sure we haven't done so, in fact. Paul Bertillon says, For low corrosion for low corrosion service like water, which pump component typically limits the maximum temperature of the process? Well, if it's water, it's not going to get higher than 100 degrees centigrade or 212 degrees Fahrenheit. So there's no limiting factor. Jake Miles says, thank you, well presented. Thank you, appreciate it. Uh, Krishnaraj Belli says, what is the maximum shaft length range available for VS4 pump with Ruhrpumpen? As I said, I believe it standard construction, it's 20 feet, but it can be longer. I will investigate that just to be sure what we can offer with a little bit of engineering. Barado Farfan says, any comment about suction conditions of the vertical pumps? And also any comment about presence of silt and sand in the media? Yeah, I mean, these are sump pumps. They are going and when they're installed in an open sump, they're going to bring in silt and gravel, and that's how they've been designed. If you think there's a lot of sand and grit, you might want to have a shaft sleeve at the bearings to make the shaft last longer. Um, yeah, that's how they've been designed. Um, the VSP Chem is a little more susceptible to solids, but it's being designed as a process pump, and process industries will tend not to have much uh, grit and sand in the product. Whereas on an open sump, yeah, open water, it's going to be sand and grit. Ed Ram says, thanks, good job. Thank you, Ed. Hamed Gavani says, could you please provide more explanation about mechanical seal plans for this pump? Okay, if it's going to be in a sealed tank, then yes, you probably need a mechanical seal to prevent the fumes escaping into the pump room. So the simplest answer would be a dry running gas seal. And that wouldn't need any seal plan at all. Although you could, if you wanted, have a plan 72 nitrogen gas to it. You could have liquid seals there. If you have a liquid seal, you're going to need to generate a seal flush plan. You could take flush from the discharge and use a plan 13 from the discharge to the seal chamber, and then it would then return to the sump. You could have a double seal and have a plan 52 or plan 53 if you wish, with an external flush. That's typically what you would use, but by far the simplest. You're only dealing with fugitive emissions. You're only dealing with a little bit of vapor, and so a dry running gas seal is the cleanest answer. Mayaresh Patil says, in the vertical pump, does minimum submergence vary with pumping liquid, or is it just a function of head and flow? Thank you. That's a good question. Yes, it's a vertical pump. If it's pumping a process fluid with a high vapor pressure, for example, NPSH might be an issue. And that is why the horizontal cylindrical tanks often have a boot in the bottom, a cylindrical boot at the bottom, so that the pump can be lowered further to get higher liquid levels in there to avoid NPSH problems. Simin Moshki says, you know that in a mechanical datasheet, differential head has been considered from the discharge flange. How much head should be added to that? Yep, you're quite right. It's a common thing on many vertical pumps that people forget to take into account the elevation from the impeller to the discharge flange. So if the process engineer has worked out the head he requires at the discharge flange, you then need to add the elevation of from low liquid level to the discharge flange. That needs to be added in, and then the pump vendors will allow for the frictional losses in the column pipe. They're in the best position to do that, so they'll add a foot or two of friction losses internal to the pump to ensure that you get at the discharge flange the pressure that the process engineer has specified. Jay Reddy says, fire pumps with enclosures and buildings for Anchorage, Alaska. Please briefly describe. Okay, it's a different subject altogether. We did cover fire packages in session 34, wasn't it? The previous one. And within that, the one are details, general details of the of packages that we could supply. So I can't cover it again here. I don't have the slides available, but if you were to look again at session 34, you'll see slides that cover that issue. Ivan Gonzalez says, hello, I have to sell a vertical pump. The cistern is below the equipment. It's 1.5 meters high. Which pump should I sell? Okay, the cistern is below the equipment. It's 1.5 meters high. So a VS4 pump would be a suitable type of pump for that. It could be mounted above the tank and lowered down, sticking below the surface into that tank, if you can allow for that sort of pump. But 1.5 meters high, you could consider possibly using a self-priming pump mounted on the floor above the equipment. So that would probably work as well. Really, I'd need to see all the product details, all the pumping system details to be able to give a proper answer for that. Brian Wookie says, is Ruhrpumpen able to modify the placement of the discharge nozzle to create a drop-in pump to a competitor's sump pump? Absolutely, yes. We will make a custom-sized mounting plate so that it will be a direct replacement for a competitor's pump. We just need to know what those dimensions are. Victor Mihangos says, is the Labyrinth a safe sealing device at the bottom of the bearing housing in the vertical application? Yeah, a Labyrinth seal will keep the oil. It's not pressurized in any way, so it will comfortably keep the oil in the in the oil chamber. Nice question here from Krishna Rajbeli. Says, what's the difference between a VS1 and a VS4 on selection point of view and cost-wise? Very interesting question. The VS4 pump is going to be the lowest price option up to a certain flow rate. And I can't tell you exactly where that changeover is, but at higher flows and higher heads, then you want to switch over to a VS1 pump because it can be multi-staged and it's also a much wider range of flows and heads. But if it fits nicely inside the VSP range, stick with that. If it's nice, and if you're pushing to the edge of it, so just have a look at the curves that I included in this presentation. If you're stretching out towards the top end of it, consider a VS1. But if you're comfortably in the middle of the range, why try harder? The VS4 will be the less expensive pump. Simin Moshki says, in the case of double mechanical seals, could we have one mounting plate or should we design separate mounting plate for the mechanical seal? No, it would fit nicely in. Remember, the mechanical seal is only going in the area where the shaft passes through the mounting plate. It's going to be a relatively small mechanical seal there, and you could put a double seal there if you wish, and separately you would mount a Plan 53 pumping system to to feed that double mechanical seal. Or if it's a single mechanical seal, you could take a flush from the discharge and pass it into the through the mechanical seal, plan 13. When the pump works at 3000 RPM, is there any limitation for pump length due to vibration? Good question again. When it's running at 3000 RPM, we make sure that the bearing spacing is less than a meter, less than 3 feet, and then you'll be fine because it'll be running below the first critical speed, so there'll be no vibration problems. Anonymous attendee has said, any relation in the 4500 and 7500 series VSP sizes to the Crane Deming 4500 and 7500 series VSP sizes? I have to pass on that at the moment. I will find the answer out to that question and give it to you in the written answers, which will come out when we send out the all the information on this last seminar. Anonymous attendee, are these pumps by default checked by Ruhrpumpen for natural frequencies of the shaft? Are these pumps by default checked by Ruhrpumpen for natural frequencies of the complete structure, pipe, plate, lantern? These questions as well for the industrial version and for the API version. That's an interesting question. Generally, it is not a problem because this is a standard product line, so it's already been tested and in that format. When you tend to get natural frequency problems is on a new, different design. So a large VS1 pump, for example, if it's not of a design that's been built before at that under those circumstances, then you're not infrequently going to get a natural frequency problem. And so then you'd have to do the calculations and either stiffen or de-stiffen make more flexible the structure so that it moves away from that natural resonant frequency. But it's not normally a problem for a standard construction VS4. They're pre-engineered and it's been pre-tested. Krishna Raj Belli, are there major API 610 deviations for the VS4? No, it's basically compliant. Simin Mosky says, the VS4 casing pump, is it axially or radially split? It's a radially split pump. Daniela has said here, in hospitality, which is the best option, VSP or VSP Chem? I'm not quite sure what you're asking there. Perhaps you can rephrase the question, Daniela. Do you mean maybe in a hospital service? I don't know what you're pumping. That's the key thing. The VSP is for water and wastewater. The VSP Chem is for chemical process or pharmaceuticals, that sort of thing. Maybe that answers your question. Nanatambi Damalingam, excuse me if I've messed up that pronunciation. Can you please explain a little bit on NPSH requirement of this pump? We would be, as manufacturers, checking that the NPSH requirement is met on the pump. What you need to do is ensure that there's sufficient head of liquid above the impeller to make sure that it operates without cavitation. So when you send us the details of the job, we would know the vapor pressure of the fluid, we'd know the temperature of the fluid, what the fluid is. We would be able to establish what the NPSH available is, and we would then tell you what the minimum liquid level has to be to pump suitably without exceeding the NPSH or keeping a suitable NPSH margin. Sometimes it will be necessary to lower the impeller in the tank, and that might mean making a boot in the bottom of the tank. And many tanks are designed with a boot for exactly that purpose. Mayuresh Patel says, can lateral analysis be performed for the vertical pump? One of the pump vendors informed me that lateral analysis is not significant for the vertical pump. Is it true? Yes and no. Yes, he's right for a standard product like this, the VSP and the VSP Chem. It's a pre-engineered product. We've already done the analyses and we've built them dozens of times. We know that they're not going to hit a natural frequency, and you're not going to get a critical speed problem. When you do get those problems is on big pumps, big vertical pumps, VS1s, VS6s. Yes, you can do. And again, we would naturally carry out the lateral analysis or the natural resonant frequency analysis when we're handling a pump of that sort of size that hasn't been built before. And if it's not clear that there won't be a problem, then we do the analysis. Simin Moshki says, what is the relation between NPSH required and minimum low liquid level? Essentially, the NPSH required of the pump, say it's 10 feet, that means you need 10 feet of liquid above the impeller. Krishnaraj Belli says, which seal plan is suitable for VS4 pump? Plan 13 or plan 14? Well, 13 would be fine. I don't see that you'd need a 14, which, no, I think plan 13 would be perfect. I want to go back to the previous question, which I answered wrongly. What is the relation between NPSHR and the minimum low liquid level? Okay, say the pump requires 10 feet of NPSH according to its curve. Well, you've got 30 feet of atmospheric pressure acting on the tank, and then you've got the level in the tank. So you might have 30 feet of atmosphere and say 2 or 3 feet of liquid level. So the pump has got a huge safety margin there. If it's a light hydrocarbon that you've got in the tank, then it might well be less. If you've got a sealed tank, we would need to consider the vapor pressure under those circumstances. So it's not an easy question to ask. It does differ. If it's an open tank, you've got no NPSH problems, quite frankly. If it's a sealed tank, yes, NPSH does need to be considered, and we need to know all the details to be able to calculate that. Arcom says, how much level of water does the pump need to operate? Yes, I've kind of answered that. In an atmospheric tank, it will pump right down until you run out of liquid in that tank, quite frankly. In a closed tank, a sealed tank, you need to consider the NPSH. We'd need to do all the calculations. There's no easy, quick answer to that. Mayuresh Patel says, what difference between a VS1 and a VS2 pump? Is a VS2 pump a multi-stage pump? Yes, it can be. VS1 and VS2. VS2 is normally one, maybe two stages. A VS1 pump can be 20, 30 stages if necessary. Krishnaraj Belli says, as an engineering consultant, what is the main concern related to maintenance point of view during offshore installation? I'm trying to think on offshore installation whether we would be using a VSP. VSP Chem could be used offshore. Maintenance, they're pretty much maintenance free. Everything you need to maintain is at the surface where it's readily accessible. You can remove the motor to access the thrust bearing, to access the mechanical seal. or you can remove, without removing the motor, you can access those components through a spacer coupling. So maintenance wise, it's it's straightforward. Um, One of the advantages of this type of pump is as wear occurs, you can readjust the impellers to compensate for that. And that can be done from the surface as well. Mayaresh Patel says, can an NPSH test be performed for a VS4 pump? I think more commonly we would do a pump down test where we would just pump it down until it lost prime. That's more common on a VS4 pump than doing um, a vacuum suppression test. Victor Mihangos says, what is the maximum viscosity you can pump? For instance, can you pump fuel oil with a sump pump? Yeah, I would say a couple of hundred centistokes would be the practical limit. But again, we would look at each one individually and see if it worked out. But yes, in principle, we can handle fuel oil. Krishna Balusu says, is the steam jacket for molten sulfur pumps designed, fabricated, and tested to PED? Is it considered an ASME vessel? If you specify it, we'll design it that way. It wouldn't be normally because it's low pressure steam, but if that's what you want to specify, we'll make you an engineered version of it that would be to PED. Simin Moshki says, which lubrication method do you recommend for VS4 pumps? Ring oil or grease? No recommendation. Grease is the least expensive and will work well on a say a non-API version. More likely to be using ring oil or oil lubricated bearings on an API one, just for closer compliance with API 610. Krishna Raj Belli again. The difference between NPSH test versus minimum submergence test for a VS pump. A minimum submergence test is what is commonly done on a vertical pump, and you just pump it down until the pump loses prime. And that's what you need to know. How low can I go? So pump it until it stops pumping. Now you know what that level is. An NPSH test would be an expensive test to do on a VS4 pump, just because you need a vacuum suppression tank that's going to be able to take the pump in through the top. So it's a bit messy. That is what we do on VS6 pumps because it's absolutely essential on an API 610 VS6 pump, but it's not really a necessity on a VS4 pump. Andavan Ramasamy says it is related to NPSHR margin requirement, whether maintaining minimum submergence is enough. In general, end users asking for an NPSH margin for VS pumps. Due to this, we urge to increase the boot depth. Please throw some light on this. Yeah, that would be right. If you're pumping a light hydrocarbon in a sealed tank, you might well need a boot at the bottom to maintain the NPSH margin. Yeah. The deeper you set the pump, the higher the NPSH margin. So it's quite common to have a 3-foot depth of boot underneath the tank. Okay, that's a lot of questions. We had 36 questions there, so thank you very much. Just wait a second more and see if there's any more, but it is getting towards the end time. Any more coming up now? No, in which case, just remains for me to say thank you again for attending and for all those very interesting questions. That's always my favourite time of these presentations is handling the Q&A. Where I haven't answered it particularly well, and that's a lot of the time, I will give you a proper answer, a considered answer in the brought together Q&A session on an Excel spreadsheet. I've got the question on the left and the answer on the right, and I'll give much more detail on those. So I will do that. Thank you for attending. I enjoyed doing it. I hope you found it useful. See you on the 21st of November, which is 4 weeks' time, for the next short course. Thank you and bye-bye.